Hello, this is Mr. Stansbury. I'm going to take you through the notes on quantiles. At the end of this, you should be able to say, I can find various quantiles given normally distributed data. Okay, so first off, quantile. What's a quantile? It's breaking data up into equal pieces. So we often break up data into what we call quartiles, and that's where we get like where the mean is the middle number, and then there's like the upper quartile and lower quartile and your minimum and your maximum. That's breaking it into 4 quantiles. And but there's all sorts of different ways to break this data up. Okay, so when finding quantiles, we are given the probability and then asked to calculate the corresponding measurement. Okay, so instead of saying it's like find the probability of it being between these two numbers, we're actually given the two numbers. Actually, sorry, between these two numbers, we're actually given the probability, and then we go back and find the number. So it's actually the opposite of what we were doing. So this is actually the inverse of finding the probability. So we're going to actually use the inverse normal function on the calculator. Okay. So I will walk you through some of those here. So example 5, a scurry of squirrels has tail length x inches long. X is normally distributed with a mean of 7 and standard deviation of 1.2. Find this here. So now this says a probability where x is less than k, and that equals 70%. Okay, so what we want to do is we want to find, like if we've got our, just so you kind of get an idea here, let's say here's our normal distribution. What we're trying to find is this here. Let's say this is where 70% of the data is, actually let's do this. So doing that, like this is 70% of the data, and then this is the other 30% of the data. We want to know what is this value right here, and that is this value k. Okay, so x has to be less than what number k, so that 70% of the data is within this range right here. Okay, so here's what we do. We get our handy dandy graphing calculator out. Okay, and we're going to go back into distribution. So we do second variables, distribution. So now we're going to use inverse normal. Okay, so we're going to do inverse normal, and when we do this, it asks us what's the area, and that's the percent. Okay, so we want to find the bottom. The area will always find the bottom, like say 70%. Okay, so if we want, and that's good because that's what we want to find. We want to find this lower 70%. So we do 0.7 for 70%. And then our mean is over here 7. So our mean is 7, and our standard deviation is 1.2. Okay. And then tail, left, center, or right. Oh, you know what? This is kind of nice, because this is asking us which piece in here. We want the left part. At least I believe that's what that is, because I actually have not seen that before. But anyway, we're good on we'll just leave everything on the left. That's weird. Okay, and we'll do this same thing on the TI-83 also if you don't have this here. So that means that our K value here is going to be we'll call that 7.6 inches long. So that means 70% of the squirrels are going to have a tail that's less than 7.6 inches, which kind of makes sense because the middle, 50%, is 7. Standard deviation is 1.2, so it's going to be above the 7, so we get 7.6 here. Okay. Here's the TI-83, because again, not all of you are going to have that same screen that we just showed there. So let's show what you would do. So we got inverse normal, and you got 3 numbers to enter. The first number is the percentage, 0.7. Okay. Then a comma, and then the second number is going to be your mean, which is 7, comma, and then your third number is going to be your standard deviation, 1.2. Okay, we close that, and look, we get 7.6, just like we did with the other one. Okay, now this one here is going to be a little bit different, but before we do that, let's take a quick little comedy break.
Oh, hey, Mike, you kind of cute. You look like Winnie the Pooh. No, I don't. Winnie the Pooh is a fictional bear with no fingers. I have fingers. I hate honey, and I got several different pairs of pants that I wear all the time. That is not a compliment, lady. Stop telling me that. Nobody wants to date Winnie the Pooh.
Oh, okay. All right, B. Now this one here is saying, what's the probability where x is greater than k? And then we're at 0.2. So now what we have, so what this is really asking is they want the top 20%. So what we want to do is we actually want to find this line here where 20%, this is what we're looking for. And this is the bottom 80%, okay? So when we go into our calculator, let's say we're doing it on this one here, we want to find this value right here. So what we're going to do is second variables, and we're going to do inverse normal, okay? And then we are going to enter in, we want to find this top 20%. So that's actually from the beginning, that's 80%. So we want to actually put in 0.8. So to find this this number here, we take 1 minus 0.2 because it's the top 20%, and that gives us 0.8. So that's what we're going to put in. Oops, wrong calculator. That's what we're going to put in right there for our first number, and then it's still the same 7, and standard deviation is 1.2, 7 for the mean, right? Put that, and we get 8.4, we'll call it 8.4. So this right here, we want to know, like right here at 8.4, the top 20% of tails is going to be more than 8.4. Okay, the bottom 80% is going to be below 8.4. Okay, so 8.4 inches for that. Okay, now just really quick to show that on here, because they've got this left and right. I bet you this will work, because some of you probably will have this. So let's do this. Second distribution, inverse normal. I'm going to try it both ways just to check to see if it works. Okay, so the area, let's do it the same way we did on the other calculator. So that's going to be 0.8. Okay, and then it's 7 and 1.2, and we're going to leave it on the left. Push enter. Come on. Probably got to go down to paste here. There we go. I thought it would let me do that. And we should get, 8.00. Let's see, what did I do? 7 and 1.2. Let me double check something here. Yeah, I see what I did. I did 1.7 instead of 1.2 on this, so let's go back. I can actually, I believe I can go back and I can edit this one. Well, I'll just do that really quick. So here's the right stuff entered in, 1.2 instead of 1.7. That gives us 8.00 as well. So that's 8.0 instead. Sorry about that. Now, something I wanted to check really quick on this here is if you happen to have this, second variables, and I have not checked this ahead of time, so hopefully this works, but we could look for the top 20%. So let's try this. I bet you this should give us the same number if I'm understanding what this calculator is doing here. And then the tail, we want to find the far right. So that means it's going to find the top 20%. Okay, at least that's what I'm hoping it's going to do. Please be 8 there it is. Good. So if your screen happens to look like that, you can do the right side, because it's when x is greater than k, we're looking for the top 20% instead of the bottom 20%. Okay? Okay. That's all we have here for the Quantiles video. If you have any further questions on any of this, please feel free to ask. Thanks.